Hi guys, welcome back. And today we are trying to cover the application of linear functions. Okay, so again, it's pretty useful in our daily life because let's just imagine you paying the gas bills. So first, it's plan A, we call the method A. It's like first charge $25 per quarter and plus 50 cents per unit of gas you will use. Okay, and method B is $50 per quarter, but only plus 25 cents per unit of gas you're gonna use. Okay, so essentially these two plans is really depend on how much gas you're gonna use or you're gonna predict you're gonna use average. So you pick the good strategy or you pay less amount of the money. Okay, that's the key idea of this. And again, it's easily draw the graph and you can find the intersection. So I think at this point, both methods you are paying are the same and there are no difference. And after later, and you will find the C1, which is method B is going to be much higher and my C2 going to be lower. Okay, let's keep going. Basically for 2D, they only give you one examples and the rest of them are purely exercise. So it's just essential for you to understand the questions and form the linear functions. Okay, then you can get the idea to calculate for the unknowns. Okay, and this is 2E is for matrix. I'm not sure it's your first time to introduce this one, but just make sure for matrix we have some dimensions or we have the rows and the columns. So if we saying this matrix is 2 by 2, it means 2 rows and 2 columns. Okay, and for this one, just keep, normally we count the rows first. Okay, then we count the columns. So it means rows times columns. Okay, so for this one, they have 2 rows and 1 column, so it's 2 times 1. Okay, for this one is 3, 3. For this one is 1, 1. So now for us, 5 is just the element or just a number. Okay, but if you add like the square brackets on the both sides, suddenly it become matrix. If you add the big brackets over here, it means this is a set and it contains one element, which is 5. Okay, so once we know the basic about matrix, we need to do some simple calculations. Okay, especially for multiplication, this one is really tricky and I will spend more time on this one. But for the addition and subtraction, it's pretty easy. So the same dimension, which means if 2 by 2 only can add or subtract with 2 by 2 matrix. Okay, cannot use 2 by 2 to subtract 2 by 1. For example, I cannot do 1002 to minus A11 and A12. It does not make any sense. Okay, it's invalid during the matrix addition and subtraction. So let's keep going. Adding, subtracting is pretty straightforward. And let's just keep going for multiplication. Okay, multiplication of matrix. And for our math method, normally we only up to 2 by 2. Okay, so 2 by 2 matrix, sorry. So it's 2 by 2 matrix times 2 by 2 matrix. Okay, so if we want to define if these two matrices can be multiplied with each other, so the first matrix columns must be equal to the second matrix rows number. Okay, in this case it can, and the final one is 2 by 2 as well. So if I have 2 by 3 times, sorry, times 2 by 3, then times 3 by 3, then I got this one are the same. So finally I got 2 by 3 matrix. Okay, if I got 1 by 2 matrix and times like 3 by 1 matrix, these two things cannot equal each other, so cannot do the calculation. Okay, and let's talk about how to do the matrix multiplication, and I will illustrate this one in the examples. Okay, So my A is 1, 3, 4, 2. My B is 5, 1, 6, 3. So the first one is this one 2 by 2 and this one 2 by 2. So our final answer will be 2 by 2 as well. Here, 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 and here. Okay. So the first one is I use the first matrix rows to times the columns and just times the corresponding one, which means A times 5 plus 3 times 6. Okay, it's this one. And then again, I use 1, 3 to times the second column. Okay, so it's going to be 1 times 1 plus 3 times 3. Okay, would be here. And once I done this one, I'm moving on to the next row, so which is 4 and 2. So 4 and 2 times 5 and 6, okay, to give me the third one. So 4 times 5 plus 2 times 6. And finally is 4 and 2 times 1, 3. So 4 times 1 plus 2 times 3, which gives me the last one, okay? And this is the essential for A times B. But what about B times A? We do it use same way, but you realize normally for two matrices, the order does matter. So A times B normally is not equal to B times A. Okay. Okay. And for this one, A is 2 times 2 matrix, B is 2 times 1 matrix. So once you multiply this together, we will get 2 times 1. Okay, matrix. So again, use 2 and 4, the first row to multiply with the columns to get this one. So 2 times 5 plus 4 times 3, and we use the second row to times again this column. So it will be 3 times 5 plus 6 times 3. Okay, this will give us the answer. Okay. Let's see the matrix and just make sure you know dimensions and you know how to do the multiplication. Okay, so this one is gonna be really important. Okay, solve the simultaneously linear equations. So normally we have three cases. Okay, 2x plus y equals 5, x minus 1 equal 4, sorry, x minus y equal 4, so two lines meet at point, which is only one solution. Then case 2, there's no solutions, distinct parallel lines. And case 3 will be infinite-many solution, so two copies of the same line. So now I can introduce some new method to you guys and help you to solve this type of problem. So look at here, if I have one line is A1, x plus B1, y equals C1. And next one is A2x plus B2y equals C2, okay? This is our two lines. So if my A1 over A2 is my B1 over B2, so what does it tell us? So A and B are in in the same ratio. So give you example, is my x plus y equals C1, 2x plus 2y equals C2. So all the ratio is half, right? 1 over 2 and 1 over 2. So in this case, you will realize if I rearrange this one, it will be y equals negative x plus C1. And this one will be y equals negative x plus C2 over 2. So gradients are the same, right? So if I satisfy this situation, which means these two lines are parallel already. Okay, parallel. So if I'm keep doing it, if I make this C1 over C2 also equal, so in this case it will be 1 and 2. So you will realize they're just two copies. So the first line just both sides times 2, get the second line. So if I satisfy all of these three conditions, sorry, two conditions, A1 over A2 equal B1 over B2 and also equal C1 over C2, there will be two copies of the same line. So infinite many solutions, right? And again, if my A1 over A2 equals my b1 over b2, but not equals c1 over c2. What's that supposed to tell us? So which means that, for example, x plus y equals 1, and 2x plus 2y maybe equals 10. So then you will realize they are in parallel, right? So which means there's zero intercept for each other. So distinct parallel lines that make the parallel line over here, which emphasize here. So no solutions if we combine these two lines, okay? Except for parallel and collinear. Rest of the case are just meeting at one point, or we should say just like intersection, okay? And this method is pretty useful and straightforward. For the next videos, my practice will focus on the 2F. So I will show you some questions from the final year exam again to help you to understand these simultaneously linear equations with two variables, okay? To use MAP method to help you to conquer or to overcome this kind of problems, okay? So for today's lesson, we just like quickly covered a little bit about linear applications. Just make sure you read the question carefully and just write down some essential notes if you need. And the second one is like matrix multiplication. Addition and subtraction, you have to be the same dimension. And for the multiplication, just remember the first matrix column must equal to the second matrix you want to multiply with the rows number, okay? Which means 2 times 3 matrix times with 3 times 4 matrix will give you 2 times 4 matrix. They can multiply with each other. And just make sure you use rows times column, but use the corresponding position to times with each other, then later adding them together, okay? And for this last part, the 2F, is just like the simultaneous linear equations with two variables. So make sure you know the ratio method, which I just introduced you now, and to get rid of the infinite many solutions and parallels. So the rest of all the other situations, all the other scenarios, they are just like intersection with each other, which means only one intersection point, which is this case. Okay. And hopefully this video helps you understand a little bit more about linear equations and matrix. And please click the like button and subscribe my videos. And if you have any comments, just write down and I will respond to you guys as soon as I can. And hopefully you guys enjoy the math. And thanks for watching, guys. Have a lovely day. See you for next videos for the practice our simultaneously linear equations. Okay, bye bye, guys.